We already have SSH key, so why need GPG? Unlike SSL certificates, which rely on central authorities, like this website is having HTTPS, so it must be secured in some kind of certificates. It uses SSL certificate, and that relies on central authority. And for this case, and more than 90% of the web is relying on let's encrypt SSL. So GPG is good so many ways. GPG stands for GNU Privacy Guard. That's understood. One important thing I must understand: content level security stack. That what does it mean? It means it provides security and encryption into the content level. Suppose I am having a message, encrypted message in simple text format. I can encrypt that message and send that message to a friend. This way, the whole communication is fully secured. Suppose we got a man in the middle attack, still no one can figure out what the text originally means. And the sharing of key is very efficient. Like you share your public key and their friend shares their public key to you. So the public key sharing is open. Anyone can see those public keys, but until and unless you both have the private key secured, the communication would be secure. That's the first thing. But there are several other aspects like software packaging. Especially, I remember Arch Linux use GPG keys to distribute their applications. Developer workflow and security, like it's better you sign your code with a GPG key, not simply putting SSH key. Identity and authentication. Yes, you can use your day-to-day SSH key, but it would be much better if you use GPG key. Why? It's a long topic to discuss. We can do that another day. Web of trust. I'm not sure about this thing. I will take a deep look at this later on. Secure package and storage. Same way, you can store your personal or like secure data on Google Drive or on AWS. Until unless you have the private key, no one can see the content of that file. But I wonder, what if in future there are other computing device like quantum computer came along? I'm not sure what would happen. Secure communication, that is the first and primary usage I understand, which I already explained. KDE specific GPG use case. Yes, KDE, the desktop environment, in simple terms Linux itself. Like majority of the Linux users use KDE, so there is a simple application called KDE Wallet that integrates very well within KDE, that implements, like suppose you store your multiple passwords or even your Wi-Fi passwords, those passwords are encrypted using GPG keys. It's better. Like if you use GoPOS, by default you will get a key, so it's better to use that key, or even if you can create your own GPG key to store all those passwords securely on your system. The standard Unix password manager. I'm not sure if the standard Unix password manager can integrate with GPG, but I understand it's something related to encryption, but I'm not sure if it uses the GPG. Software supply chain security. Yes, already mentioned those things. Various distributions use GPG key to rely on so-called security and trust. Web of trust, I'm not sure. This was already mentioned. Hardware security token integration. I'm not convinced about hardware security. Like if we want to secure our content on the base of hardware level, there is no way. Like if Windows tried to make something on Windows 11, they encrypt using some kind of security check. The name of the chip was TPM, but the TPM is not secure. Even like you will find various YouTube videos how to crack those. So I'm not sure how TPM would survive. For that reason, we must have a auto-destructible hardware. And if you see auto-destructible file system, TRUCTABLE file system, self-destructible file file system. See, this is not a new concept. Like if you want to access the secure partition, it will destroy itself if like you brute force the password, but it is achievable. Like first step would not be to brute force the encrypted disk. The first step would be to simply copy that disk. Like if you have a copy of that disk and later on you try to brute force that thing, even that soft copy gets lost, it would not be a good solution. There are various hardware solution, but no one has made up a concrete one. Like they tried to make a toy like system, like it will get destroyed, but it doesn't work on practical use case. Automated data ingest and compliance. Yes, like if you are a big tech company, you must use some kind of GPG on transit to keep safe your data. So let's try to create some GPG key and make some hands-on with GPG. Let's put that command in another terminal. RSA and RSA, like I see ECC, sign and encrypt. That is the default one. If I continue select, it provides curve 25519. That is the way to go, I think. But what this example says, RSA 4096, but I am going on another direction. It should not be the case. Like if we set expiration, we must revalidate or reproduce our GPG key in that interval. Like we will be bound, but it's better to have a zero expiry and do that key refresh later on as you wish. So it's better to provide 0. Is it correct? Yes. Why real name? Let's provide my real name and real email. Now comment. Let's provide passphrase. By the way, this input method looks so cool within terminal. Like today's HTML developers would be so much angry to see this type of UI interface. Okay, it is also giving some warning, like it was not 8 character long on password complication. I want to continue with this one, take this one anyway. See, the GPG key is generated. And what if we want to list keys? I can see this is the key and this is the key ID, ED25519. It is the updated one. Still, I use ED25519 on my SSH key also because it produces very little and it actually works on graph. That is the reason why it provides so efficient encryption. Then there are some example commands. Like those are the commands to export your public key, and this is the command for exporting your private key. But what if you want to interact with someone, like having a secure communication, encrypted communication? Like if you use Google's email server, the email is visible to Google's internal bots and so many things. Even I think let's not go to that route. Simply if you want to communicate with your friend having encryption, GPG is the best one, and it's better you use GPG for that case. How you use? First you will have to import your friend's public key, then you can like verify using fingerprint, then you encrypt using this command. The email ID can be varied, like this one should be the ID, this ID. And for the decryption, the command is simple, as you already have the public and private key, your private key and your friend's public key, both you have, so the decryption is simple. But here I want to achieve something else. This is the thing I want to achieve. So let's verify if I am on the correct path. Yes, I am on the correct path. Let's provide this one, repo add followed by -s. That means it will secure using this private key followed by this command. What if I add -s and -k over here, -s followed by -k, and just provide the, yes, it is warning, but getting some warnings. Whether it is warning, will those warning actually affect? I'm not sure. Let's abort this and let's delete those extra multilib database. See, first of all, this is not multilib, we are on extra. So ls multilib. So I see there are multilib.db, zz and files. Those are there. So it's better I delete those files first, remove all those multilib, and as I see those extra database files are also there. So I'll have to remove those as well. Extra dot star rm. So it will remove all extra database files. Now it's time we provide the extra db command. Yes, see, it was a success to make all those packages using some GPG keys. Today's session seems complete. Let's see on another topic.